Pure and Applied Chemistry. It is an international federation of national atomic organizations that represents chemists in individual countries. UPAC naming rules are very important because without them, we will not know how to draw its structure or distinguish them from the different types of hydrocarbons. Methane is the most important and most common hydrocarbons, and it's also the smallest one. Followed by it is ethane, ethene, ethine, propane, and propene.
Carbon is an organic compound that consists only of carbon and hydrogen, and there are several types of hydrocarbons like alkanes, alkenes, alkynes, cycloalkanes, and aromatics.
Hydrocarbons that contain only single bonds. The steps to name the alkanes based on the UPAC are: write the alkane name of the longest chain of carbon atoms, then number the carbon atoms starting from the end and near a substituent, and finally give the location and name of each substituent, in alphabetical order, as a prefix to the name of the main chain.
In this example, each person represents a carbon atom. Their hands represent the bonds, also their foots. Their shoes represent all the hydrogen atoms. Finally, we can call this compound a propane.
To draw the structural formula for an alkane, there are only 3 steps. The first step is draw the main chain of carbon atoms. The second step is number the chain and place the substituents on the carbons indicated by the numbers. And the third step is add the correct number of hydrogen atoms to give 4 bonds to each C atom.
Have a general formula CnH2n. They have fewer hydrogen atoms than the alkanes. The extra balance left over occurs as double bonds between a pair of carbon atoms. Double bonds are more reactive than single bonds, making the alkene chemical more reactive. The UPAC rules for alkene and cycloalkene nomenclature are: first, the "-ine" suffix ending indicates an alkene or cycloalkene. The longest chain chosen for the root name must include both carbon atoms of the double bond. The root chain may be numbered from the end nearest the double bond carbon atom. If the double bond is in the center of the chain, the nearest substituent rule is used to determine the end where numbering starts. Finally, the smaller of the 2 numbers designated to the carbon atoms of the double bond is used as a double bond locator. If more than one bond of double bonds is present, the compound is named as a DN, 3N, or equivalent prefix indicating the number of double bonds. Finally, and each double bond is assigned a locator number. This example is the same as one as the first one shown in the alkanes. The difference here is that the middle carbon atom doesn't have one shoe, due to it has a double bond with the third carbon atom. According to the UPAC rules, this compound will be called propene.
In order to draw the structural formula for the alkanes, we first need to draw the main chain of carbons given by the name, then locate the double bond in the chain given by the number in the formula. Next, place any alkyl groups or substituents on carbon atoms. Finally, add the correct number of hydrogen atoms to give 4 bonds to each atom. The alkynes are unsaturated hydrocarbons that contains 1 or more triple bonds between carbon atoms in a chain. Triple bonds involve the sharing of 3 pairs of electrons. Its general formula is CnH2n-2. The simplest and most commonly used alkyne is ethine, C2H2. The nomenclature of alkynes is identical to that of alkanes. The only exception is the ending -ine.
In this example, we can see that there are 3 carbon atoms represented by 3 persons. The carbon in the middle contains a triple bond with the third one. With this, we will have only an hydrogen atom in the last carbon atom. If we follow the UPAC rules, this compound will be called propyl.
In order to draw the structural formula for alkanes, first we need to draw the main chain of carbons given by the name. Then locate the triple bond in the chain given by the number in the formula. Place any alkyl groups or substituents on carbon atoms. Finally, add the correct number of hydrogen atoms to give 4 bonds to each carbon atom.
Feeling my way through the darkness, guided by a beating heart.
The aromatics are organic compounds that contain benzene ring as part of their structures. They were named because of their strong aroma, but now they are defined as anything that has a benzene ring. They are 6-sided structure with single and double mobile bonds, C6H6. Naming aromatics. Substituted benzene compounds are named the same way as cyclic alkanes. Substituted benzene rings are numbered in the way that gives the lowest possible numbers for the substituents. Another way naming the benzene compounds are using the terms ortho, meta, and para. Ortho means 1 and 2, meta 1 and 3, and para 1 and 4.
Hydrocarbons derivatives are molecular compounds of carbon at least one or other element that is not a hydrogen. Organic halides are organic compounds in which one or more hydrogen atoms have been replaced by a halogen atom. Common organic halides include phenols, that are chlorofluorocarbons, and teflons, polytetrafluoroethyl. Naming halides use the same format as branch chain hydrocarbons. The branch is named by shortening the halogen name to a fluoro, chloro, bromo, or iodo. In drawing organic halides using UPAC names, draw the parent chain and add branches at locations specified in the name.